fellow teachers and students, and good afternoon, class.
Good afternoon, Mr. Sarah.
I think you may sit down. Our lesson for today will be on a rough inclined plane. In our last lesson, we looked at a smooth inclined plane. Now this time we'll be studying a object that is moving down a rough inclined plane. All right, let's consider this. All right. If you can remember from our last lesson, we had looked at a rough, or rather a smooth inclined plane, and then you saw that this object will be moving down. We are not considering any of these frictional factor. At this time on a rough inclined plane, we will have to consider all the forces that will act on this. Right, just imagine as this, let's say, crate or box is up here, there is always a vertical component, let's say the vertical component that is acting on this, and that is the weight of the object or the box. So we can simply solve this one into two components, the vertical component and the horizontal. All right, for this we can have the work done as mg right, it should be the cosine of this angle. All right, the normal, when it is here, the center of gravity will be always causing this to act in that. So the weight of that will be, we can assume that this angle is almost the same as this. Let's say if it was 25 over here, this will also be 25 degrees. So when you are trying to calculate work, then this one will be, the vertical component will be mg sine theta, force cos sine, or rather the force cos theta times the distance. And for this horizontal component will be k sine times c, distance as that it is more. Now also in that you will find that if that is sliding down, this object is sliding down this rough inclined plane, there is always a frictional force that is acting in the opposite direction. Okay, there is always a force that is always acting in the opposite direction. Or if you decide to put this box down here and then if you push it out this way, there is always a frictional force that is acting downwards. And that frictional force is sometimes constant in each one of these objects or the planes. And that is known as, or it is given by this small letter u, a Greek letter which is mu, and that is the of static friction. Okay, that is a coefficient of static friction, or it can be coefficient of kinetic or kinetic friction. Okay, there is a constant that will be found almost in any one of those planes. Okay, and it is not constant for all of the planes. It can be quite different for each one of those planes. So that is how you can solve to come up with the work done, especially when an object is sliding up or down a rough inclined plane. I have the information which I will give you now, and what I'd like you to do is copy those information, and 1 or 2 questions will be given based on that information. So I want you to quickly write down this information. Pilot students, you can also have the notes down or write the notes into your exercise book. Okay. If the friction, or let's say if the F is the frictional force overcoming friction and the S is the distance moved along the plane, all right, given that example there, then we can put this equation as mgh, that is when it was up there, and then when it is moving down it will have some kind of kinetic energy, and plus the friction that is going to be overcome, and then you have the distance in which this object is moving. the same thing. This time, if you have to project that object out of plane, then loss in this will be equal to the gain in this energy plus the energy used in overcoming friction, and that is F times S. F times S is the energy that is used in overcoming friction. So it is likewise the same thing as the one that you equation that you have earlier. All right, lost in mgh equals to gain in kinetic energy plus that. The same thing this time, it is loss in kinetic energy will be equal to the gain in potential energy plus the energy used in overcoming friction. Alright, I will explain to you two examples and then I will give you only one activity question. Alright, one of the examples given here is, alright, this is just an example. If you want to copy after my explanation, you can copy. Right, we have a body of mass 250 kilogram, it's pushed up 8-meter ramp. Okay, at this time it is moving up, but you also find that it is, if it is still a rough inclined plane, there will be some kind of frictional force existing. So in here, that inclined plane is making an angle 20 to ground. Right. If let's say this one is 250 kilogram. Okay, the force will be 2,500 newtons. Now, how much of that work is done if the coefficient of static friction is 0.35, or if it is the kinetic friction is 0.35? All right. I will give you time to copy that information. Right. Looking at this from a diagram here, you are trying to push this up, and the motion of that will be up this way. You have also the weight force of this object that is downwards. The frictional force is this time moving downwards because you are moving that object up. So in this case, that is the normal, meaning that in any case you can find that it is always a force that is opposite to the weight. Okay, the force that is opposite to the weight force is simply the normal. The normal is this way. All right. Using that equation, we can now come up with, all right, if you want to find the work that is done, P equals to mg sine theta minus the coefficient of static friction times cos theta. That is the same angle giving you mass times acceleration. So when you have to combine this and then find this, you come up with mg sine theta plus mg times coefficient of static friction times cos theta, and that would give you mg because you have this, and when you have to factorize this, you have sine theta plus u cos, and the work done equals to mg as sine theta plus the coefficient of static friction times cosine of that angle. Okay, that is how you can find the work that is done, especially when you are dealing with a smooth inclined plane. All right, so just copy that example and then also the diagram. After this, I will give you one activity question to solve. Okay, you will learn more of this, especially when you are in grade 12. Anyway, to show you how you can calculate the coefficient of static friction, you can be found by the force, friction force over the force normal. Okay, that is how you can arrive with the coefficient of static friction. Okay, just quickly have that. If you finish the diagram. Okay, just have this. All right, once you finish copying that information, I'd like you to look up, I'll go through one example and then explain to you, and then the activity question will be given to you as a homework. You can carry it, solve it, and then come back in our next lesson. We'll have a look at the homework question. So once you finish this, I'd like you to look up. Now let's say this is an object having 300 Newton, or in other words, you can assume that the mass is 30 kilogram. Now you are trying to take it to a certain height over here, and that is an inclined plane having a very rough surface. And you require about a force of 140 or 147 newtons. You will need to apply a force of 147 Newton to bring it over here. All right, how do we find the work that is done, especially at this? If you have to look at the distance in which it moved, let's say it was 5 meters. Okay, since this one comes about because you have a frictional force that exists between this and the surface of this. Otherwise, it will be that 300 Newton times the height in which you are taking it. But because there is a friction in which it is existing between, you require a force of 147 newtons to get this one done. So how do we know the frictional force? All right, frictional force in this case will be, okay, just use a piece of, okay, friction will be equal to 147 minus the cosine of 147. Because you require that force to bring it up here, if you minus that, it will give you, the cosine of that will be, can somebody give me your answer from the calculator? So 127. Okay. $127, is it? Okay, 127.83. Okay. Anyway, you have this one as 147 minus 127.83 will give you what is it? Okay, what is the answer when you minus this from 127.8? 147 cos 30. Yeah, that is correct. Okay, what is it? 90? $98.17. Okay, that is the frictional force that exists between this, and if you minus 127 from this 147, you get 98.19. Okay, that is the frictional force. Now, how do you calculate the coefficient of static friction? It is quite a constant that will exist between here, and it is quite different for each one of these planes. So in that you will have the okay, the frictional force that is 19.17. Okay, 19.17. All right, that is a frictional force. If you want to calculate the coefficient of static friction, that is the U that was given. U equals to, it is 19.17, or in other words, the friction over the normal. Okay, in here you have the cosine of that 300. Cosine of that 300 will give you this answer. Okay, what is cosine of 300? What is it? All right, cosine of 30 times 300. Okay. 59.81. All right, that will give you the coefficient of static friction at this point. So I'm just explaining to you how you can work out the coefficient of static friction. You can come up with the normal force that is acting, or even the frictional force, especially when you are dealing with any object that is sliding down an inclined plane. All right, this is your activity. You don't need to worry about this. I'm just going through and explaining. You copy this information, and then this information, the work that I gave you is based on what I gave you, okay? Not on what I've just explained to you. All right, just quickly copy this activity. We'll have a look at it in our next lesson.
Up the plane. What do you think?
Yeah,
Up the plane.
2 meters up the plane. For this question will be 2 meters pulled up the plane, making an angle 10 to the horizontal if the coefficient of kinetic friction or static friction is 0.2. Calculate the work done. Okay, it is pulled up the plane. All right, quickly to summarize what we went through in a lesson. On a rough inclined plane, if you are trying to solve or work out the amount of energy that is involved in moving either an object down that inclined plane, or let's say up that inclined plane, there is also a frictional force that is considered. Now the constant of that frictional force is sometimes known as the coefficient of static friction or coefficient of kinetic friction, because when you are moving it, there is a constant of friction that is holding, and it happens, or it is quite different to different materials. So in here, to calculate the work done would be simply considering the two components. One is the vertical component, and then you have the horizontal component. Okay, on the horizontal component, when you are trying to calculate, that will be using a sine ratio because it is now vertical to that, or rather it is horizontal, parallel. But for vertical component, you will be using a cosine ratio of that angle in produce. So I'll just leave this question for you to do as a homework, and then we'll discuss that question in our next lesson. And our key phrase for today would be rough inclined plane. Okay, good afternoon class, and good afternoon pilot teachers. Okay, thank you. You may sit down.